Welcome to EDU World Space.
So in this question, the components of a plane stress at a point are shown, right? So what we need to do is that we need to determine that whether this system or this material would fail or not, right? So we need to determine that whether this failure whether the failure occurs or not, right? And we need to base our solution on the maximum distortion energy theory. And the thing that is given to us, the information that is given to us, is that the yield stress sigma sub y is equal to 700 megapascals, right? So let's start with the solution. This question is very simple, right? We are shown the components of a plane stress at a critical point on a thin sheet of shell, right? And we need to determine that whether the failure is basically yielding, right? Whether the material yields or not. So whether this material yields or not, and the distortion. And we need to base our working on the maximum distortion energy theory. And the piece of information that is given to us is that yield stress is equal to 700 megapascals, right? So let's start with the solution. Now the solution is very simple. So um, now, as we found in problem 10.59, that the distortion energy theory can be written in terms of can be written in terms of sigma sub x, sigma sub y, and tau sub xy, right? So it can be written as sigma sub y square is equal to sigma sub x square negative times sigma sub x times sigma um, sub y plus sigma sub y square plus 3 times tau square sub xy, right? So in the figure, as you can see, that taking the x as horizontal as y and y as vertical and right and upwards positive, we get that sigma sub x is equal to 500 megapascals, right? Sigma sub y is equal to negative 200 megapascals, and tau sub xy is equal to 150 megapascals. Right now, what we are going to do is that we are going to simply plug them in. Um, we are going to plug this into what we found in problem 10.59, right? So that is simply sigma sub y square is equal to sigma sub x square negative the product of sigma sub x, sigma sub y, positive the square of sigma sub y square plus 3 times tau sub xy square, right? So just plug in the values First of all, we have 500 square, negative 500 times negative 200 plus square of negative 200 plus 3 times 150 square, right? So calculate it and you will get that sigma sub I square, uh, sorry, not sigma sub y square, only sigma sub y is equal to 457,500, right? And yeah, sorry, this is for square, my bad, right? Excuse me. So now I'm going to take under root of this, so of this equation, and I'll get that sigma sub y is equal to 676.3875 megapascals, right? And that is approximately equal to 676.4 megapascals. And since you can see over here that since 676.4 megapascals is less than 700 megapascals, so it means that then the material does not yield, right? The material does not fail, right? Failure has not occurred. And this conclude our answer.